Hi, I'm doing Paul McWhorter's Arduino Uno R4 lessons, and I'm up to lesson number 74, which is all about using PyQtgraph on a PC in my case to generate a sine wave. Now, for those of you who've been doing Paul's PKW lessons, this might seem a bit familiar, and he did do the same thing, and in fact he ended up using 3 sine waves for red, green and blue. But I looked at his code and I thought, that is very odd. Why are you doing it like that, Paul? Because I could remember that he was using numpy, and I would use numpy. So here's proof. Here's PKW lesson number 115, the code that I actually had lying around, and there you can see he's using numpy. He's using creating numpy arrays. He's doing everything. So I could not understand why he was doing it. I thought, is he having a senior moment and he's completely forgotten it? I know people's short-term memory does go as you get older, but who knows? So then I saw on YouTube lessons 112 to 115 have completely gone, and on Top Tech Boy it's gone. So I have no idea what he's doing, but he has decided to eradicate them. Now this is his lesson and I don't like it. I'll just run through. I mean, everyone will have watched it so they know what it's doing. Right, you're just importing that, then setting up 2 arrays of the right length, 0 field. Then you're doing this for loop to set up the right times. Each one, the time step, it's increased by time step, and then getting the value of the sine and putting it in the red arrays. And then here I can't understand. A lot of people wouldn't be able to follow this, but I kind of forced myself. Now he's set up with his array. He's for his red data and his time data, he's shifting everything 1 position to the left and then adding the new value onto the end, which is a bit strange. So I will show you how you can do it in using numpy. Right, as you can see, from numpy import arange, sine and pi, and here that sets up a numpy array starting from 0 going up to, but not including period, time steps. So the time data there, from doing that, is exactly what you get after you've finished in that for loop. Time data there, down there, time data will be the same as my time data, and equally the same with red data, but and that's so much easier as well. Now repCount I'm actually using instead of time, because I wanted to make it easier to understand rather than comparing T with repCount. So down here we now have 2 arrays, one with the times up, for the first period, and the equivalent sine waves. So we come in here, and repCount was 0, now it's 1. So you're now adding to your time data. With numpy arrays, if you go the name of a numpy array plus something or other, what it does is it leaves the existing array alone, but it returns you a numpy array with the thing that you're adding on, in this case that, added on to every single whatnot, every single element. So that is the same as Paul shifting up by one, shifting up by one, shifting up by one, shifting up by one. And then I didn't want to have to recreate the sine wave thing, which is the red plot. So I was using ind there to get to the right position of the array, if you get my drift. So ind is initially equal to repCount. Then after a whole period goes by, then I don't want it. You know, it will go repCount is 499, repCount is 500. There it means that ind will be 499, and then it goes back to naught. So I'm using that ind to find the place to coincide with my current timeData NP array. I want to find out where I am, so I use ind. You just have to try it out. It's too difficult to jolly well explain for someone like me. Right, so you're taking the values in redData from that point to the end, and then you're adding on the values from the beginning of that array to the point you want it to be. Now, if you're using an ordinary array, you wouldn't need the list, but numpy arrays do not like it when you try and do that plus that. No, it says you need to convert me to a list. So you've got a list of the second lot, and then you're adding a list to the first lot, and it jolly well works. So we will first of all run Paul's program. Now I'm having problems with my computer racing off and doing updates and things, so if it does that, then all the times will be rubbish. This is Paul's program. Right, there you go. Doinky, 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 doinky. Ah, measuring period. Oh, that's a bit high. Oh, that's a bit better. Oh, it's starting to race again. Everything's going horrendously wrong. Right, we'll stop that, and then probably I will have the same problem. It's racing. I don't know what it's doing. Measuring period. What I will do, I'll stop that. I will see if by disconnecting from the internet, will it stop? Will it stop? Please, please, please stop. I could close my Google window. No, it seems to be better. Right, we'll try again. Right, there's a nice curve. Doopy 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 doo. Doopy doo. Oh, no, it's still doing it. But it is something my computer is doing. It is, I don't know if you can hear that racing. Oh, it's looking okay now. Right, so I think you can agree that both of my programs, Paul's program and my program, are both working equally as badly all the time, but that has nothing to do with the programs. Right, this is my homework. This is my homework. I haven't done anything really to my homework. Oh, I forgot to say, the time that I'm using for the measured period, as opposed to Paul was doing this if it was less than or equal to naught and then greater than equal to naught. I'm just using if ind equals naught, that's the end of a period. So yeah, that's a lot easier. So we will close that. This is my homework. All I do is every time I update the graph, I'm just sending that. That looks a bit dodgy. I should have done it with an F string. Sending it to the Arduino. I'm not bothering to show the Arduino because there's nothing of import with my program. So I will run this program. But I need to be connected to the internet. I knew I'd fall for that one. Right, will it or will it not start racing again? I'll close that. I'll close that. Right, fingers crossed. There we go. Donkey, donkey, donkey. It's high, therefore it's bright. It's going down. It's off. It's going up. The timing will be completely out because I don't know what has got control of my computer. I always blame Windows updates. So that's my homework.